Hello everyone, myself Anusha. I am studying MSc second year at Manasa Gangotri, Mysore. My presentation is on supervised learning, classification, regression and types of regression. First, we know that what is supervised learning. Supervised learning is the machine learning task of inferring a function from labeled training data. The training data consists of a set of training examples. In supervised learning, each example is a pair consisting of an input object and a desired output value. A supervised learning algorithm analyzes the training data and produces an inferred function which can be used for mapping new examples. Here is the diagram to show how the supervised learning process can flow. Supervised learning process consisting of two steps: learning and testing. Learning learn a model using the training data. Testing tests the model using unseen test data to access the model accuracy. Accuracy is equal to number of correct classifications by total number of test classes. Overview of supervised learning. In order to solve a given problem of supervised learning, one has to perform the following steps. Determine the type of training examples. Before doing anything else, the user should decide what kind of data is to be used as a training set. Gather a training set. Thus, a set of input objects is gathered and corresponding outputs are also gathered either from human experts or from measurements. Determine the structure of learned function and corresponding learning algorithm. Complete the design, run the algorithm on the gathered training set, evaluate the accuracy of the learned function after parameter adjustment and learning. The performance of the resulting function should be measured on a test set that is separate from the training set. Supervised learning consisting of two types: classification and regression. Regression means predict the output value using training data. Classification means to group the output into a class. Example: we use regression to predict the house price from a training data and use classification to predict the gender. Examples of supervised learning. The best example of supervised learning is customer discovery. Predict whether a customer is likely to purchase certain goods according to a database of customer profiles and their history of shopping activities. Regression. What is linear regression? Learning. Supervised algorithm that learns from a set of training samples. Each training samples has one or more input values and a single output value. The algorithm learns the line, plane or hyperplane that best fits the training samples. Use the learned line, plane or hyperplane to predict the output value for any input sample. Linear regression consisting of two types: single linear regression and multilinear regression. Single dimension linear regression has pairs of x and y values as input training samples. It uses these training samples to derive a line that predicts value of y. The training samples are used to derive the values of a and b that minimize the error between actual and predicated values of y. Then the equation becomes y dash is equal to ax plus b. We want a line that minimizes the error between the y values in training samples and the y values that the line passes through. Or put another way, we want the line that best fits the training samples. So we define the error function for our algorithm so we can minimize that error. Equation becomes E is equal to summation of I is equal to 1 to n y dash minus yi whole square. To determine the value of a that minimizes the error e, we look for where the partial differential of e with respect to a is 0. Derivative of del e by del a is equal to 0. Then the final equation becomes summation of I is equal to 1 to n yi xi is equal to a into summation of I is equal to 1 to n a into xi square plus b into summation of I is equal to 1 to n xi. To determine the value of b that minimizes the error e, we look for where the partial differential of E with respect to B is 0. Then the equation becomes summation of I is equal to 1 to n yi divided by n is equal to a into summation of I is equal to 1 to n xi divided by n plus b. By substituting the final equations from the previous two slides, we derive equation for a and b that minimizes the error. Then the final equations for a and b is equal to a is summation of I into yi into xi minus y bar into summation of I into xi divided by summation of I xi square minus x bar into summation of I into xi. B is equal to y bar into summation of I into xi square minus x bar into summation of I into yi into xi divided by summation of I into xi square minus x bar to summation of I into xi. We also define a function which we can use to score how well derived line fits. A value of 1 indicates a perfect fit. A value of 0 indicates a fit that is no better than simply predicating the mean of the input y values. A negative value indicates a fit that is even worse than just predicting the mean of the input y values. Then r square is equal to 1 minus summation of I into yi minus y dash whole square divided by summation of I into yi minus y bar whole square. Multidimensional linear regression. Each training sample has an x made up of multiple input values and a corresponding y with a single value. The inputs can be represented as an X matrix in which each row is sample and each column is a dimension. The outputs can be represented as a Y matrix in which each row is a sample. Our predicated Y values are calculated by multiple the X matrix by a matrix of weights W. If there are two dimensions, then this equation defines plane. If there are more dimensions, then it defines a hyperplane. We want a plane or hyperplane that minimizes the error between the y values in training samples and the y values in the plane or hyperplane passes through. Or put another way, we want the plane hyperplane that best fits the training sample. So we define the error function for our algorithm so we can minimize that error. Equation becomes E is equal to y power t into y minus y power t into x w minus y w power t into x power t into y plus w power t into x power t into x into w. To determine the value of w that minimizes the error E, we look for where the differential of E with respect to w is 0. We use the matrix cookbook to help with the differentiation. We also define a function which we can use to score how well derived line fits. A value of 1 indicates a perfect fit. A value of 0 indicates a fit that is no better than simply predicting the mean of the input y values. A negative value indicates a fit that is even worse than just predicting the mean of the input y values. Then r square is equal to 1 minus summation of I into yi minus y dash whole square divided by summation of I into yi minus y bar whole square. Logistic regression. Logistic regression is a type of classification algorithm based on the linear regression to evaluate output and to minimize the error. Named after the method it uses to evaluate the output, that logit function. What is logit function? Changes of happening one event over chances of this event not happening. Here is the graph to show how logit function work. In previous slide we saw the graph of logit function. This logit function is bounded over x and unbounded over y axis, but we need y axis to be bounded to classify them. Hence we take the inverse of the logit function. Therefore logit inverse of a is equal to 1 divided by 1 plus e power minus a is equal to e power a divided by 1 plus e power a. A is some number. The other type of regression is ridge regression. Ridge regression is the another type of regression in machine learning which is usually used when there is a high correlation between the independent variables. This is because in the case of multicollinear data, the least square estimates give unbiased values, but in the case of collinearity is very high, there can be some bias value. Therefore, a bias matrix is introduced in the equation of ridge regression. This is powerful regression method where the model is less susceptible of overfitting. Below the equation used to denote the ridge regression where the introduction of lambda solves the problem of multicollinearity. Beta is equal to x power t into x plus lambda into 1 whole power minus 1 into x power t into y. Lasso regression. Lasso regression is one type of regression in machine learning that performs regularization along with feature selection. It prohibits the absolute size of the regression coefficient. As a result, the coefficient value gets nearer to 0, which does not happen in case of ridge regression. Due to this, the feature selection gets used in lasso regression, which allows selecting a set of features from the dataset to build the model. In the case of lasso regression, only the required features are used and the other one are made zero. This helps in avoiding the overfitting in the model. In the case of independent variables are highly collinear, then lasso regression picks only one variable and makes other variable to shrink to zero. Here is the graph to represent lasso regression. Below the equation that represents the lasso regression method. Polynomial regression. Polynomial regression is another one type of regression analysis technique in machine learning, which is same as multilinear regression with a little modification. Polynomial regression, the relationship between independent and dependent variable, that is x and y, is denoted by the nth degree. It is linear model as an estimator. Least mean squared method is used in polynomial regression also. The best fit line in polynomial regression that passes through all the data points is not straight line but a curved line, which depends upon the power of x or value of n. Here is the graph to represent the polynomial regression. While trying to reduce the mean squared error to a minimum and to get the best fit line, the model can be proved to overfitting. It is recommended to analyze the curve towards the higher polynomials can give strange results on extrapolation. Below the equation represents the polynomial regression. Linear regression. Bayesian regression is one of the types of regression in machine learning that uses the Bayes theorem to find out the value of regression coefficient. In this method of regression, the posterior distribution of the features is determined instead of finding the square. Bayesian linear regression like both linear regression and ridge regression but is more stable than that of simple linear regression. Here is the graph to represent Bayesian linear regression. Thank you.